Right. Hi. We're going to go through a couple examples on hypothesis testing in chapter 15. Specifically, these examples will be on proportions. Right away in chapter 15, they talk about hypothesis testing with proportions, and then they'll talk about with means or averages. So it's important to notice like what kind of problem you have. Is it a proportion problem or a mean problem? Because then you know which formulas to use. So let's read through this. The National Center for Education Statistics monitors many aspects of elementary and secondary education nationwide. Their 1996 numbers are often used as a baseline to assess changes. In 1996, 34% of students had not been absent from school even once during the previous month. So perfect attendance, not been absent for 34% of students have not been absent. In a 2000 survey, respondents of 8,302 students showed that this figure had slipped to 33%. So officials, of course, would be concerned if students attending was declining. The question is, do these figures give evidence of a change in student attendance? So we're wondering if the attendance has changed, that proportion has changed, right? I see I have percentages in this example, 34%, 33%. This is a proportion problem. I don't see like average number of people that day or anything with the word average or mean. I don't see the word standard deviation either. If I see the word standard deviation in a problem, then that tells me it's a mean problem, an average problem. So right here I have a proportion. So I hopefully I've read the text. I know what formulas to use. Now on this example, oops, scrolling down. On this example, we have a baseline of 34%, and sorry, I have a baseline of 34%. I don't know, has this changed? Is this evidence of a change? So my null hypothesis is always an equals. Draw. My null hypothesis is always an equals. I can get this to work. There it goes. So null hypothesis. I'm working with a proportion, so I'm using the letter P for proportion. I assume that everything has stayed the same. My null hypothesis, everything has stayed the same. So I'm assuming that percentage, that proportion is still 34% or 0.34. And then my alternative hypothesis is what I want to prove. I want to prove there's a change in student attendance, that proportion is changed. So in this example, I want to prove that it's not equal to 0.34. Now, if it asks, do these figures give evidence that, that our proportion has increased, I use a greater than. As this figures give evidence that proportion has decreased, I do a less than. But since it's asking change, I'm going to put a not equals to. Now let me pause my recording and go plug in my laptop. Okay, laptop's plugged in. Let's finish this problem. So our test statistic, because we're working with proportions, is Z. Now, the formula that we use, since we just have one sample of data, is it's P hat minus P over a standard deviation. Now, the standard deviation we're using in this example is for proportions. So I wrote down my formula for my test statistic. My standard deviation in this example is the formula, the square root of P times Q all over my sample size. So in this example, P, I already indicated was the 0.34. I already said that in my hypothesis. So that's the 0.34. Q is always 1 minus P, and then over our sample size. Our sample size was 8,302. So when I plugged this in my calculator, I got 0.0052. So now that I know my standard deviation in this problem, I'm going to go back to my z. P hat is always the proportion from the sample. P hat is always the proportion from the sample. So it has changed to 0.33. And P, I already indicated, was 0.34. And then I want to divide by 0.0052. And I get Z is 1.92. So here's my Z, 1.92. So this is my test statistic, Z equals 1.92. I almost said any questions so far. So my p-value, because of my alternative hypothesis, is a not equals to, it's a two-sided test. This should be negative 1.92. Because my alternative hypothesis is a not equals to, I am performing a two-sided test. So when I get to my Z table, I want this lower tail and this upper tail. Because of my alternative hypothesis is a not equals to, it's a two-sided test. If it was greater than, I just want the upper tail. If it was a less than, I would just want the lower tail. But because it's not equals to, I want both sides. So what I'm going to do is I'm going to go to my Z table, which I have right here. My Z table, I'm looking for negative 1.92. I'm looking for that test statistic I just found. So negative 1.9 and then the 2. Right? Can I write on this? I think I have to put annotate. Draw. So I have the negative 1.9 and the 2. So here's that negative, or that's positive 0.274. So going back to exit that. This side was the 0.0274. So what do I need to do to get this side? It's going to match because this is symmetric about 0. So this is why I multiply that number I found in my Z table by 274. I need to practice writing on my computer. And I'll get that 0.0548. This is our p-value. Because it's two-tailed, my not equals to symbol and my alternative hypothesis, I need to find this end of my tail and this end of my tail. Because our Z table is symmetric, I really just need to find one end and multiply it by 2. So here's my p-value, 0.0548. Oh, I see that it kept that on the screen. That's kind of annoying. My conclusion is that my p-value is a little too big. My p-value is greater than 5%. So I fail to do anything. I fail to reject my null hypothesis. It's not surprising that the attendance has changed to 0.33. So I can't conclude anything right away. If my p-value is small, what I just saw, if my p-value is smaller than 5%, then that event is unique, it's surprising, it's not likely to happen, right? Our p-value is a percentage. The fact that my event would occur if our null hypothesis was true. So because in this example, my p-value is a little bit bigger than 5%, we say that it's not unlikely to occur if it's still true. So in this example, I'm going to just say that attendance has not changed since 1996. There's no evidence to suggest the change has happened. I can't conclude that the change has happened. So I'm going to write a little sentence about that. Always, I want you to write your p-value if it's bigger or smaller than 5%, and then do you reject your null hypothesis or do you fail to reject your null hypothesis? And then write a sentence. So usually when we fail to reject something, I start off by saying there's not enough evidence that there's not enough evidence I'm just going to say that attendance has changed significantly. Attendance has changed significantly. Okay, I'm going to stop the recording now, and then I'll finish up the other two examples I have.